Um, so I'd like to call this meeting the Homebrew Robotics Club May 2025 to order. Welcome aboard. Today's presentation will be Paul Bouchier. He's the president. Did I pronounce that right, Paul?
Close enough.
He's the president of the Dallas Personal Robotics Group. I've known him for several years, I believe.
This is my second year, but I did a couple of terms back around 2010, been a member for a lot of years.
2010. Well, the Dallas Personal Robotics Group, I got that right, DPRG, has been around since the 80s, if I'm not mistaken, right?
Correct. 40 years last year.
Yeah. You guys started the same year as the HPRC, 1984.
That's what I thought.
I think that's the Seattle Robotics Society, I think they call themselves, and also the Southern California Robotics Society. So anyways, great, longtime homebrew robot builders. Paul's going to give the presentation this evening, and he's going to cover some of our favorite topics, including ROS, and talk about Linorobot 2, and talking about AI programming with AIDER, I believe, right? AIDER. All righty. So first thing we do is we'll talk about industry news. Does anybody have any particular industry news they want to mention?
Yeah, I just saw something from Zenith, had a home robot, which was like a wheelbase and a torso with two arms. And they were showing something. I don't know if that was a real robot or a AI simulation, but it was Zenith Robots. And I didn't know that Zenith was still in business.
Mm-hmm. Well, the name has some value, doesn't it? Let's see. I just did a quick Google. This looks like something homebrewed. Not that there's anything wrong with that. Anyways, why don't you Google, see if you can find something on it, maybe post a link. Humanoid robots seem to be all the rage these days. I think AI is doing a lot of that. I just posted in the link China, UB Tech, talk about launching a $20,000 home companion robot. We'll see how that turns out. Of course, now with tariffs, it's going to be $40,000, right? I don't hear any laughs out there. There it goes. Somebody posted in the mailing list. By the way, everybody knows for the mailing list on the Homebrew Robotics Club homepage. About a nice video about the Tesla, and in particular the hands, how they do the hands. When you think about it, I do mapping and navigation, but at the end of the day, when you arrive at your destination, it's all about the hands and manipulating stuff. So interesting stuff. Any more industry news this evening that somebody wants to talk about or mention? Hey, Jim, good to see you. And Dee Dee, all right. James, of course, the usual suspects. Mr. Mike, Charles, good to see you. Dr. Ed, not to be confused with Mr. Ed, the horse. All right, let's move on to club news now. What do we got in club news? Anything?
I guess the only thing I got for that would be Servi and I are trying to plan another RoboMagellan Day later this month. I think 4 weeks from now, the 21st. So 3 weeks from Saturday.
So I would do it this way. You guys do your RoboMagellan robots and be there. Just post to the mailing list. And folks that want to go there, and make it. I like coupling it to the challenge, because in this little, more club news.
That was the idea of the day.
June is our challenge month, It's all just like that. It's summer. And as everybody knows, the HBRC Challenge, we started in 2003. So this is like the, I don't know, 22nd year or something, but we do them 3 times a year. So it's like 60 events. We were sitting in the library. We met at the Cupertino Library at the time, lamenting the lack of building activity in the club. And, everybody had a robot. They put it together and did the show and tell, and it sat on the shelf, and there it sat. And that was kind of the end of it. And so we observed, Captain Obvious here, that activity coincided with contests. We did a line following and a maze busting, but it's like these contests had things that had to be set up, and somebody was always unhappy. You had winners and losers and this and that, and so that's where the TableBot Challenge was born. Robot, and we do it in phases: March, June, and September. Phase 1 is go to the table, back, forth. Phase 2, push block off the edge. Phase 3 is push block. So it increments the. The point I'm trying to make is that so we've done this for 22 years, and we're in phase 2 now for June. So the whole meeting is nothing but show and tell. So we're a builders club. Everybody's expected to show up and show what they're building. Heavy on the show, light on the tell. What else? Club news. I don't see Marco there. I think Marco may be off, maybe out this evening. I think Maker Faire is coming up in September. So, time's moving fast. Hey, Steve, how are you? And so any other club news this evening? So again, next month is the challenge month, and I'll be bugging you all month long. Don't take it personal. I'm talking to myself. And the more robots you bring and show, the less you have to listen to me. So there's that, right? Well, yeah, okay. Let's see now. So what next thing is what I need help with. Is there anything somebody's working on, that they have a big question, problem, something that, trying to figure something out that maybe wants to pose it to the group?
Yeah. Hi, Alan. Since sometime in May, all of my joysticks stopped working. And I have 3 different platforms, 2 joysticks that I move between them. They were working fine with Jazzy all through April. And after update and upgrade, which touched everything in ROS, I think, joysticks just don't work. I.e., I know my joysticks are working because I can do JS test, and it sees it, and I have permission. And it's slightly different depending whether it's a Raspberry Pi 4 or a Raspberry Pi 3. On a Raspberry Pi 4, I can echo the joystick topics, but they never get to command velocity. And it's not a stamped versus unstamped, because I can drive them keyboard teleop. On the Raspberry Pi 5, I don't even echo the joystick topics. Never gets there. Never loads the joy node. So I'm suspecting it's something with the ROS library for joy that's got buggered up somehow, but I don't know what the resolution is. I've even trying to build it from source. It builds no errors, but it doesn't work. So that's what you get for upgrading and updating.
So does it still work off and on, or is it just not work anymore?
It does not work anymore.
Keyboard
teleop works.
Put that together in the mailing list. Put that together on the mailing list and post it and see if you get some responses.
Yeah.
Any other what I need help with this evening? Something in the.
I have one. Hear me, Camp?
Yes.
Go ahead, Michael.
Okay, I'm trying to use PWM on a Raspberry Pi running Ubuntu 2404. This probably works fine running Raspbian, but on Ubuntu 2404, even though the program says everything is working, there's no signal coming out to the GPIO pins. And there's a special command you can run to see whether or not the pin is actually executing. But anyway, the Claude AI, says that hardware overlay is just not enabled under Ubuntu 2404. If anyone has successfully got this to work using, again, just the hardware PWM pins under Ubuntu, not under Raspbian, send me a note about it, please.
Is this a Pi 4?
Pi 5. That's important. It works under the Pi 4. It doesn't work under the Pi 5.
Yeah. Mike, do you have the right overlay? I had a similar problem with
Might have been
camera 3.
22. I don't.
Camera 3 versus camera 5 on the Raspberry. Camera 2 versus camera 3. You had to use a different overlay with a different camera.
I believe I am. I've tried just the PWM overlay, and then there's a PWM 2chan, which is the one I'm currently using. But both have the same failure.
There we go.
When you build it, do you get any warnings about libraries?
No. Even the test code that the AI suggested, you can read the registers for the PWM, and you can see that the pulse width and the duty are all fine, and enable and disable and all that. When you read back the registers, they're all fine. It's just that no signal shows up on the GPIO pin itself.
And it's not a permission thing.
I've fixed that problem too.
That sounds like an overlay issue where it's not configuring the port.
That's what the AI is saying.
Yeah.
I didn't know if someone has a magic Raspberry or Ubuntu something that'll fix the overlay problem.
That's interesting too, because hi-hats rely on overlays to set hardware configuration.
Yeah,
Right.
other overlays are working fine. It's just this one. In fact, if you try to load either the PWM or the PWM 2chan overlay directly, it comes back and says, no, this overlay is not available.
Hmm.
There's a Python GPIO library.
Yeah, I could do it with software, but I'm wondering if anyone's figured this with hardware. And I've got a dongle that'll do this, but again, I'm trying to see if anyone has figured out how to get around the hardware issue, the overlay issue.
Put it together on a put it together and ask it on the mailing list and get some follow-up.
So the difference is the hardware on a 5, especially IO hardware, is different. It's a different chip.
Yeah, I think this case, it's whoever built Ubuntu 24 didn't
If
include.
it works in Raspbian, but it doesn't work in Ubuntu. It's clearly a software issue.
Yeah,
But put it together and put it on the mailing list. Are there any other what I need help with out there? All right, let's move into show and tell. All right, and I'll have a combination what I need help with and show and tell. For the longest time, I've been trying to get this ultrasonic cone on my mock turtle bot, and with help from Mr. Mike and Sergey last night, we've got the cone, and I've actually got the cone horizontal here. Let's try a waypoint through, and I'm going to do a Floorbot challenge phase 1. We'll do it with breadcrumbs, though. This is nav2 waypoint following. But you'll see when the homebrewed ultrasonic sensor is triggered, and the homebrewed ultrasonic sensor has a story behind it too, Mr. Mike and Ralph Ganock. We took the simple publisher and the ROS 2 tutorial and change the hello world text to a range object, and it's actually functional. Now my next goal is to make a plugin for the nav stack so that when it detects something, it navigates around it, safeguarding the superstructure on top. So this is the smart table. Okay, let me bear with me. Can't open enough screens at the same time. So yeah, here I've currently got a nice new tabletop on him. That's Smarty 2 there. Okay, and so this is a physical robot. It's a Create 3 with DL06 LiDAR. Bear with me. Displays. Camera. Yeah, there's the camera. And all right, and action. So when it gets near something, you'll see the ultrasonics trigger. There it goes. There's the cone. Very exciting, huh? Can you see the screen?
Yes.
Yes. Okay. So right now the cone's out there. There's the ROS wrapper telling me, okay, so the cone's switched on here, or you can see it in the RViz, I should say. So the next goal is to make a plug-in so that when it detects something, it actually goes around it.
This screen share is delayed.
What is the distance remaining?
I don't know.
Well, it says right on the screen, it says distance remaining 12.4 meters.
That's
to
the
endpoint that you've set.
navigation system telling it how far he has to go to reach the goal that he set up.
That's
Yeah.
in that map. Okay, I
I'm
understand.
scratching my head asking why he's going around in circles. I'm going to help him out a bit with teleop keyboard. Actually, let's look at, and I'll be brief here because I know time's rolling. Turning, okay, so it's running the spin. It was running the spin recovery behavior. It seems to have run it for several cycles there. Let's see if he's broken out of it. Passing new path to controller. So he seems to have broken out of it to some degree.
Camp, you're just visualizing this now. It's not being used in your route planning.
What's your question?
Is it being used in your route planning now? Your route planning?
Well, okay. There's a physical robot now that's in my living room, okay? What we're looking at is the visualization, okay? And this terminal screen here is the navigation stack, so it tells me what's going on in navigation, okay? And it's not going well for my demo, okay? That having been said, I'm going to change the goal. I've clicked 2D nav goal. I'll come up here, point, press, drag mouse up, and let's see if he snaps out of that. All I'm trying to show is the ultrasonic cone, okay?
Yeah.
My demo is going sideways.
I was
The answer
wondering
is the
whether
cone
your
is
new
not
sensor
doing
was impacting
navigation.
your.
It's just doing visualization.
Oh, of course. That's the blah, 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 blah. I have to put it in the plugin to navigation, and it's not in the plugin. But we had it before, and it was funny during the ROS2 discussion meeting. We put it in, and it was vertical. It wasn't horizontal. It was funny. So the new thing is I've made it horizontal. Bear with me here. Teleop keyboard. Let me get a hold of this damn thing.
Camp, what's your QoS on that?
I'm not checking that right now. It works. It's worked fine several times when I'm not running Zoom. Here's my H-top. H-top's currently at 10. That's not bad for an i9, but regardless. Let me just get him back in range here. All I'm trying to show is that ultrasonic cone, okay? That's the breakthrough. That's the thing I needed help with, and we got it running, and that's the demo I'm trying to show. Bear with me. So let's just go here. 2D nav goal, point, press, drag, mouse up. This is autonomous. I'm not using my fingers.
Very good. Thank you, Julie.
So there, when it gets to the wall, you see the ultrasonic cone, and the RViz. That's merely yeah, and yeah, that's just for the visualization, or that's just for the visual there. Sorry, hang on. All right. What else? What else has a show and tell this evening?
Does your sonar distance appear in one of those white menus that are drop downs?
Yes, you can select it in displays, and you can tell it what color you want it to be and so forth. And you saw the funnel display in the RViz, right?
What I was interested in is the decimal values. Are they showing up in one of those menus? Like that one that said the distance left, which was the distance left to travel for the complete the map. Is there also one for the ultrasonic sensor that would tell you how many meters or centimeters that it's scanning till it sees something or so it bounces off something?
The ultrasonics is simply measuring obstacles. It would be used for navigation to avoid the obstacles. Yes. There's no reading as to how far to go, in particular relative to the obstacles. That would be more about odometry and that sort of thing. Any other show and tell this evening?
Got another show. I'm going to show and tell.
All right, Nathan, go for it.
All right. So as you're well aware, you know how projects, you start working on something and then you put them on your shelf and forget about them for 3 years. This was a balancing robot that I started building when I got my first 3D printer, and then I finished building it, and then RoboGames 2023 got announced, and then I completely forgot about it. So over the last couple of weeks, I have finally got it working, though. Now it is no longer just some interesting shelf ornament, and so I have it now balancing. Well, it does work. There we go. Now it stands on its own, more or less. Doesn't really do a good job of staying in one spot, but it does. It does stand up on its own. You can kind of push it around, and it will comply with the direction you push it.
I think he's frozen in time there. That's awesome.
That's one way to do a balancing robot. You just have to freeze the internet.
I have
Perfect stabilization.
I think 300 RPM gear motors.
There you are.
I'm using the PIO blocks on the RP2040 to do counting the ticks on the encoders, although I don't do anything with that information yet.
How hard was the IMU code?
I guess the signal cut out.
Yeah, we lost.
Yeah, it looks like we're on our own here.
We lost the
Lost the maker nexus.
Maker Nexus.
I'm gonna go wiggle the thing.
For 5 volts to drive all the electronics in the other one.
Oh, that's weird. Cutout.
Yeah, we were having a bit of that earlier. Paul, you still there?
Yeah, yes, still here.
There's our presentation anyway.
I have a show and tell too. A brief one.
Well, let's give them 1 minute and then it's going to be yours, Jim. Hang on.
This-
So I don't even think they realize they're offline. Tim, why don't you go ahead?
Me? Yep.
Yep.
So briefly, yeah, I worked on recently a way to for voice commands.
Depending on my
Oh,
battery,
Hold on, I think
they
they're
are.
back. They're coming back.
but I just have a 5 amp battery to 5 volt, regulator, and I haven't found too many problems with that. As long as the battery's above 7-8 volts, the regulator always is a.
Oh,
This is gonna be rough.
shake a cable.
That's it. Wiggle the wire.
They're out in the hallway or something, some kind of thing.
Oh,
Yeah,
So
they'll be
before
back.
we get into the main presentation, can I ask everybody who's not presenting to go on mute? That would help. Thanks. As you were saying, Camp.
Well, I was just saying that we may want to go ahead and, okay, look, they're going to come back again. But the problem is from their end, amongst the Zoom group, nothing's an issue. But regardless, the issue is I'm stating the obvious, the connection at Maker Nexus.
they may be
So I see.
able to disconnect and reconnect or something.
Well, no, they've done that, and so the
Oh.
Wi-Fi there is just weak. Now I see Kyung's connection here, but it's muted, and I wonder if that's his phone. I wonder if that's no, they wouldn't have muted themselves because Nathan was in the middle of a presentation. Anyways,
You want me to-
why don't you go ahead and say what you were going to say, and when
I
they
was
come
just gonna
back, we'll
do-
just
I have been working on a way to take, your robot commands and be able to have the robot respond to the closest command that you said using an AI embeddings type model. So, for instance, you have all these different commands that are literal, and if you don't say them right, the robot won't do it in traditional parsing. But now what I've done is created what's called an embedding array for each of these by calling this AI function. And then whatever you say, it checks to find the closest one in this weird embedding space, which is this is a trained model that maps like human language into this multi-dimensional space, basically an array of numbers, and then you can check the distance from the closest one. So, so for instance, I have something like,
what could possibly go wrong?
yeah, well, you have something, basically, if the robot doesn't understand what you're saying from this list, then it tries to find the closest embedding.
Yeah, I agree with you.
So if I say, for instance, hey, Orange, hide RGB window. Hello there. Oh, that didn't work.
Ben, it's nice to see you again.
The text in the indicated it had parsed it correctly.
Yeah, maybe. Well, what I'm trying to show it here, let's do a different one. Hey, Orange, show your eyes. Oh, that one I have. Let's try a different one. Hey, Orange, show depth window.
Okay.
See right here, it said show depth window, parser failed looking up closest command. Well, I don't really want to see the depth window. And it found it, open depth window. So that's the idea here is you'll be able to
Okay. You have a link for that?
This says, what time is it? If I say, hey, Orange, what's the time?
It is Wednesday, May 28th at 7:37 p.m.
See, it said parser failed, looking up closest command, what time is it? What's the time? Anyway, that's the basic thing. And yeah, I can post you the info. Basically, it's called an embeddings model. And this is, yeah, and I'm using Olama. It's called Olama on your computer that will can evaluate AI models on your right on your PC. And this one is only a few million parameters, so it can run really fast on, it's not billions and billions like the normal ones. This is a lightweight model. And so,
Very
yeah,
good. Thank you very much. That's awesome, Jim.
thanks. I'll show more advanced stuff at the next meeting.
Yeah, if you can post a link to that, that's very interesting. What else? Any other show and tell this evening before we get into the main presentation?
I have one too.
Oh, there they are.
You want to like yell at them and tell them that they're flaky?
Hey, Kyung, Paul said you're flaky.
Yeah. So
Yeah.
so it's yeah, I'm making a hand, open source hand called Luca. So I haven't hooked up the motors yet, but you see the cables. So 11 cables, like 2 for each finger, like this, and 3 for the thumb. And yeah, I will have to hook up motor then. So yeah, but mechanical parts are done, I guess.
The springs on the fingers, or
Yeah,
Oh,
so
nice.
here's the spring. So
Nice.
I guess motor is just like a pulling it to
Okay.
end.
Is that Jim Burnham there? Hey, buddy, it's good to see you.
I know, I need to pay my fee so I can officially be here.
That sounds good. Hey, Kyung there, he'll take your money. I get half of that. All right. Any other show and tell this evening?
Next time.
Let's do the main presentation now. The president of the Dallas Personal Robotics Group, Paul Bouchier, will talk about the DPRG. He'll talk about ROS and Linorobot, and he'll talk about ADER. That's AI pair programming for developing ROS nodes. Paul Bouchier, ladies and gentlemen.
Are you seeing my slide?
DPRG and Linorobot 2.
Okay, well, thank you everybody for having me here, and appreciate your hospitality. I'm a bit of background about me. I call myself an embedded systems engineer doing hardware and software design, but I was fortunate enough to have 9 years of professional experience in robotics on autonomous full-size trucks, doing system test and calibration and hardware and software subsystem design, and 15 years of personal experience with ROS. So have had some fun with robots, and Camp asked me to tell you, bring you some news about the DPRG, the Dallas Personal Robotics Group, which is an adult-focused hobby robotics club. And I'm much like HBRC. I'm going to talk about the activities we have and the communication channels we have. And then something ROS-ish, I've been working with Linorobot 2, which is a set of software packages that lets compatible robots navigate using ROS 2's Nav2 stack with no programming required. So I'll talk about what, why, and how. And then ADER is a terminal-oriented pair programming assistant, and that a couple of us have started using in the club and been quite pleased with. So the DPRG, founded in 1984, similar age to the Homebrew Robotics Club and the Seattle Robotics Society. We typically have about 40 paid up members and a considerable number of regular guests. We have contests, a weekly video call, monthly in-person plus remote meetings for the tech talk. So that part, you kind of like what we're doing here tonight. And then we do some outreach activities. And so the contests, in May, we hold an indoor contest, which we call Roborama. And we have half a dozen contests there, line following, 4 square, go around in a square and try and get back close. This one I'm showing on the bottom left is called 6 Can, where the robot has to go out and bring 6 cans back to a goal. And then in November, we have Robo Columbus, which is modeled after Robo Magellan. It's a more accessible version of Robo Magellan. RTK GPS is permitted, but it's basically a similar kind of thing. And so just let's see, you'll see video here. Okay, so that's my little robot, mini bot, which I'll talk about. It is it's a robot platform, and the last Roborama, and there was collecting cans, and then Robomo, competing in Robo Magellan, in Robo Columbus. Similar kind of concept. We put a tennis ball on top of the cone. If the tennis ball falls off, you're considered to have moved the cone. So then we have, in addition to the contests, we have a weekly Robot Builders Night virtual. This is a video conference, and it's a free form, sort of a little like what you all did at the beginning of this meeting. A bit of show and tell, a bit of
this actually meshes up with the ROS discussion group. So it's like you could dial in earlier for this and then go right into the ROS discussion group at 7 p.m. Pacific time, which would be 10 p.m. East Coast. I think that puts it at like 8:30 your time, something like that.
7:30 Central.
So
that would, yeah.
And then the robot news section, it happens every Tuesday. So if you can't get enough of robots, come to RB&V. We do DPRG news, kind of like you all do, presentation queue, and then open mic. And generally about 12 to 20 participants from across the country, sizable contingent from Canada. We do kind of a cool thing. We record the video as you do here with Google Meet. We've got a Google Workspace subscription, which gives us Google Meet long meetings longer than an hour and full recording and transcription. So then what we do is we have a workflow that takes the transcription and summarizes it, sends it off to ChatGPT to summarize, and in the top right picture, see one of our members showing off his robot to the group. Bottom right is the summary produced by ChatGPT, and then I edit that in the wee hours of Wednesday morning and send it out to the email list to kind of keep the group, the rest of the group kind of plugged into the activities that are going on.
That's awesome.
And then a monthly meeting is on the fourth Saturday at 10 a.m. We have in person with pizza and virtual. Usually have a tech talk. So it's partly social, like some of you are doing at the Makerspace, part learn something new. Recent topics, we've had talks on how to get 5 copies of a PCB for $2 from JLC PCB, how to train an AI camera to recognize cones. Bob Cook came and talked to us about that. We had an AI camera symposium, had a talk on CAD design for 3D printing. Sometimes we do a show and tell. And then we do a quarterly robot power lunch where we meet at a local restaurant or bar in a segregated area. And then we do a little bit of outreach as well. We typically do Moon Day. You can see us up front here at the Frontiers of Flight Museum in Dallas, showing off our robots, and typically do some kind of support for local high school robot teams like FIRST or VEX. And then we've got a number of communication channels. Our website has all the past and upcoming meeting info at dprg.org. Like your group, we use Google Groups for email communications, but it's mainly used for announcements. What we implemented, we chartered a comms team early last year to figure out how to get us a replacement for our aging and creaky email listserv, and they chose Google Groups for email and Discord for chat. And so the Discord server has been a real boon. And I've got a link here if anyone wants to join it. I'll be giving the slide set to Camp at the end of this. Or you can email president@dprg.org and get an invitation. But we use that for technical discussion, organizational discussion, and planning and other discussions. And so Camp keeps asking me, well, have you joined our mailing list? Well, yes, I joined the HBRC mailing list, but I had to turn it off because it had so much info. The emails were just flowing across continuously with discussions that I wasn't following, all interleaved, so I find that the Discord server has been a real boon. So we've got sections like
I don't get Discord at all.
So it's a chat server. So I'm
just saying.
Yeah, we'll do Facebook for you.
Oh, no.
Facebook. I get all my news from Facebook.
So we've got like topics like member projects where we'll discuss Roby the robot restoration and have pictures. You know, you can post pictures. It's a rich media thing for discussions on ROS. We've got a ROS topic. So it's basically lets you take all the threads, all the email threads that you all have flowing across into everybody's email inbox, and lets you have more of a pull model where you get notified that someone posted something, but then you can go and look at what topics it's in, and if you don't care about fabrication, then hey, you know, who cares? So it lets you have more threaded discussions and do search in particular topics. So that's the essence of.
I just signed up as you were speaking. Quite easy. Nah, looks like a really good interface.
Well, thank you and welcome.
Well, thanks.
And so this little dot here next to AI means that someone posted something in AI. So click on that, and so Kareem says OpenAI now thinks he's British. So anyway, like typical kind of chat interface. It's a pretty neat platform. And then we've got our YouTube channel. We've got playlists. Is perhaps the easiest way to navigate it. And we've got like our monthly meeting. You can view the full playlist of Tech Talks, and then the DPRG website is a little bit sick at the moment, so your mileage may vary, but it's got a big orange box for Robot Night Builders Night Virtual. That'll take you to the joining info, and then under news, get the latest news, is the historical log of the Robot Builders Night Virtual. These are just links to the YouTube channel, along with the chat record and the meeting and the AI generated meeting summary. So those are the DPRG communication channels and our activities. And then there's Roby, the 7-foot-tall DPRG mascot. And let's see. So he's an animatronic. He's a four-off robot. And pretty basic. A bunch of the guys that back in 2016 built him, and he's been to a few shows, and then he got put on a shelf for quite a few years, and we're just starting to bring him back and modernize him, brush all the dust off of him.
What's his name?
Roby, R-O-B-I-E. I don't know why he doesn't have two B's in his name, but whoever named him, he's the DPRG mascot. So
he's awesome.
The website, you'll see he appears on the like he's our icon, our mascot, and so they built a 7-foot-tall version of him, and we're working on he's got a head tracker, or face tracker that follows.
That's what we need. That's what we need. Maybe then we get some respect.
The Atlanta Hobby Robotics Club mascot, when I was part of that, was a self-driving beer cooler.
So let's see. Before I move on to Linorobot, does anyone have any
it was a big cooler,
comments on DPRG?
I'm sorry, what was that, Paul?
Before I move on to Linorobot, does anyone have any questions or comments on DPRG? Nope. Okay.
Looks like an awesome group, man, just like the HBRC.
Yeah, real similar. Bunch of nice folks, very technical, very involved in building stuff, regular competitions, interest in technical talks. Yeah, it's a neat group to be a part of, I got to say. So I've been playing with Linorobot and getting progressively deeper into it. So I wanted to share what I've found, my experience with it. I competed it in the challenge last weekend in 6CAM. So it's a software platform for mobile robots. That features hardware flexibility, low cost, and almost turnkey to run the NAV2 stack. So the Linorobot nodes enable NAV2 to navigate through a map. And user apps can ask NAV2 to navigate, and NAV2 will avoid obstacles. And it supports a lot of robot configs, microcontrollers, motor drivers, and and I forgot to turn on slideshow, so sorry about that. Let me do that real quick. Yeah, so specifically in the Watt, it's a kind of a you build the hardware, Linorobot provides the software for compatible robots. So it supports the two-wheel drive, four-wheel drive, and Mecanum robots. Supports for microcontrollers. It supports an ESP32 Pico or TC running the Arduino environment, and then has a range of motor drivers that are all of the pulse width modulated flavor, either with the NA, NB style of direction and enable, or an ESC, servo controlled output. So like an ESC driving a brushless DC motor, or a continuous rotation servo. So pretty flexible on motors, motor drivers. Motors should have a quadrature encoder. It supports 3 lidars over Wi-Fi, so you can send your Wi-Fi and your control data directly up. Your lidar and your control data directly up to a laptop, for example, over the Wi-Fi, or you can send it over USB serial to a onboard computer on the robot, Raspberry Pi or whatever. So a variety of different lidars supported and IMUs. The hardware architecture, this shows the onboard computer version where the laser scanner and the depth sensor, if you have one, are USB connected to the robot computer, Raspberry Pi or whatever. But if you're Wi-Fi connected, then your robot computer is some computer out on the net, and Wi-Fi travels, carries the data and the lidar data and control data and status up to the robot from the microcontroller, whatever flavor of microcontroller you've got. And then the microcontroller drives the motor drivers, the encoders, and the IMU. The software architecture, so it's you have the ROS2 with the nav stack running up on the robot computer, and then runs micro ROS down on the microcontroller. So the microcontroller runs the IMU driver, encoder driver, motor driver, PID loops, and so forth. And micro ROS supports supports having code down on the microcontroller create publishers and subscribers, and maybe provide services. Haven't used that, but I think it would. Anyone who's used micro ROS will have found that it's based on DDS. So those of you who do ROS are probably intimately familiar with the pains of DDS, and I experienced those pains in spades because my home network is based on an Eero 6 mesh network, which doesn't support a multicast. So therefore, you can't do ROS over it. So therefore, I can't run my ROS nodes on a Raspberry Pi and send the ROS GUIs off to my laptop. So DDS, and so if you're plugged into ROS development, you'll know about the Xeno stack, and I've tried Xeno. Xeno seems to work pretty well, just for ROS stuff. But the problem with micro ROS is it's got DDS deeply embedded into it because it uses something called an XRCE DDS driver as the layer underneath the ROS library. Well, there's a move afoot to replace that with a XenoPico project layer, so that you'd have Xeno talking to Xeno with XenoPico running on the microcontroller. They seem to have gotten publications, ROS PubSub implemented at this point. So that's an interesting direction that I, for one, would be interested in taking this this code base in that direction. So that's the what of Linorobot. So I'm just going to do a quickly drop out of sharing and stop sharing. Am I? Do you see my video now?
You're no longer sharing.
Great. So let me just. Oh, I didn't. I dropped out a bit prematurely. Sorry about that. Let me just reshare. Okay, so I'm going to launch the Linorobot code here. So let's see. Am I sharing my screen now? Are you seeing the terminal window?
Yes, we see your terminal screen.
Okay. So I launch Linorobot in two phases. One is the
Hang on a second. This is an actual physical robot, Paul?
Yep. And I'll show it.
Just want to be clear.
Yeah. I'm taking a big chance here. I'm doing a live demo.
We love it. We love it.
So we're launching Linorobot 2 Bring Up, which is one of the packages in the Linorobot 2 stack. Running bringup.launch, telling it the microROS transport is UDP, microROS port is 8888, LiDAR transport is a UDP server on port 8889. So we fire that off, and all of these colored messages where it's telling you it's created subscribers, topics, publishers, and the associated DDS entities, data readers, data writers, and so forth. So that has now started the microROS agent, and if we do a ROS2 topic list, we've got some, and it started a handful of other nodes as well, like it would typically start the localization node, but anyway, so you've got the scan data unfiltered, and it's publishing TF, the IMU, it's diagnostics comes out of the microROS node, out of the microcontroller. You've got command vel, so you can actually drive the robot at this point with a joystick or with a keyboard teleop. So next, I'm going to fire up ROS launch Linorobot 2 navigation, the navigation launch file, and.
So have you already made a map?
Yes, I have. And oops, and let me just put this guy down and set and move this, shrink.
I assume you use Slam Toolbox to make the map.
Correct. Yeah, all that good nav stuff, nav2 stuff works on Linorobot. So it's pretty neat. And let me.
That's amazing.
Pose estimate. We'll see how this works out. Okay, not too bad, but a little bit off. So we'll just repose it just a little bit. Looks like it needs to go down just a little bit. But it's pretty much on in direction. There we go. That doesn't look bad at all. Okay, so now we can do the usual, tell it to go drive somewhere.
That's awesome.
That's so there's Linorobot using the MPPI controller. One of the club members got the other
Hey,
plan of
Paul, in the
Yeah.
display on the left, can you scroll down and see if there's local controller?
there.
Yeah, controller, click that checkbox. I want to see
Yeah.
the local cost map. That's awesome.
Yep. Yeah, so it's all the nav2 goodness working on a well, I'll tell you more about Linorobot here in a little bit. But I'm just going to unshare now. Let's see, and okay, I should have unshared and you should be seeing my video now.
We are seeing your video feed, yes.
Okay.
And Maker Nexus. We're keeping an eye on those Maker Nexus guys.
I'm just going to do another navigation, and you'll see the robot come into view from behind me. Okay, so up it goes. It's under my workbench, and here it comes.
That's awesome. It looks like the real Linorobot too.
It's a real Linorobot too.
We had Juan Miguel do a presentation here. I think it was a year and a half ago or so.
Yes, I spoke to him yesterday morning, and he told me about that.
Excellent.
Told me that he'd talked to you all. And so this is about as simple a piece of a robot as you can get. A couple of TT motors with Hall effect quadrature encoders on them and a battery underneath. A wave share general driver for robots, and a LiDAR, LD19 LiDAR on it, and an IMU up in the corner there. So real simple.
Hey, Paul, I want to get a screenshot. Hold the robot up next to you. Let me get a good screenshot here.
Sure.
Screenshot, or it didn't happen. Move a little to the other side so you get in the camera too.
Always loved how extra the little blue ring of LEDs on
How's that?
LED LiDARs is.
That's good. All right. Got to work with what you got.
All right. Okay, so let's see. I'm going to.
That was awesome, Paul. Very good show.
Thank you, Cam. So I'm just going to go back to, so, got enough of the theory. We got to do, we got to run some robots and make them earn their keep, right?
Yeah, that's right.
Beer run.
Working and just on the robot part.
Okay, so why? So that was the what, along with the demo. So why might someone be interested in Linorobot 2? Well, this top heading pretty much summarizes the value prop of Linorobot 2. It enables low-cost robots with a flexible hardware configuration, and it's easy to configure. And I'll go through that here in a tick. And it runs nav2 with all that means, which is a lot. So I've got a parts list here, and and the most expensive parts on it are the robot microcontroller with the robot driver at $30 almost, and the LiDAR at 60, and the battery at 20. And so this is a $130 robot. On the right, I'm showing a config with a depth camera on it and a Raspberry Pi, so that would bump it up to 350 or so. So that it's a low cost robot. But when you're looking at a robot and asking yourself, do I want to go with a particular software stack or hardware robot, you should look at what the options are. What other options are for a ROS2 navigable robot. So obviously the one that jumps out at the front of the list is TurtleBot 4. Light and the lights about 2K, about 1300, the regular one's about 2K. It's the canonical ROS2 robot. If ROS doesn't work with TurtleBot, then ROS is broken. But it does not use microROS. The robot motion control and sensing is done by the Roomba iCreate 3 and has a serial connection from the Linux PC on the robot. So it is a specific hardware implementation with limited hardware flexibility, assuming a Create 3 base and specific sensors out of the box. Another choice you could have is Maker's Pet. They have robots now. They'll be launching a dustbin style robot in 2025. They work with KAIA.ai ROS software. So the robot has a microcontroller on board, a Wi-Fi connection to ROS running in a container on Windows. So again, it's a very specific implementation with limited hardware flexibility. I think you could probably roll your own KAIA.ai software and configure it somehow, but then you got to dig into it. So this is not to denigrate it or the TurtleBot, just to point out the constraints that come along with these products. The other one that is turnkey navigation is Yaboom for about 400. But what's neat about that is they've got Automatic Addison tutorials. If you haven't come across Automatic Addison, automaticAddison.com, he's done just a ton of tutorials on ROS and ROS navigation and just about everything to do with ROS, ROS1, ROS2. Great set of tutorials, highly recommend it. He's even got a tuning guide for the nav stack in which he enumerates the variables in the nav2 params.yaml file that he changes to make robots work better than the stock YAML file. Then there are ROS robots on AliExpress that I don't know anything about. I don't know like what level of software they come with, whether they'll work with nav2 or whatever. I feel like KAIA.ai software is closest in terms of flexibility to Linorobot. So I think there are other. I think in summary, there are other reasonable options to build a ROS2 robot. Oh, and we mustn't forget Camp's Roomba-based TurtleBot.
The mock bots.
Yeah, the mock TurtleBot.
Thank you.
Which probably is very reasonably priced, but again, it targets a particular.
We'll cut you a deal.
He says good things about it.
We'll cut you a special deal.
Yeah, right. But again, it targets a particular config. So just going back to one slide to the central value prop of Linorobot, low cost, enabling low cost, flexible hardware. So you choose your motor controller, your LiDAR within certain limits, and easy configuration to get running up and running on nav2. I think it's unique in offering that combination of values.
Pardon me, I have a question. Where's the microcontroller in that list for the actual that runs the micro ROS that?
So the microcontroller is an ESP32 on the WaveShare General Robot controller.
Ah, okay.
And you program it. So I'll go into the software configuration here in a little bit. But in a nutshell, it's the thing that had the ESP32 Wi-Fi is what sends the UDP packets off to my laptop running the ROS nodes.
So that's like it's a motor controller, and the
Yes.
ESP. It's got all combined. You don't need a separate motor controller board.
Right.
That's nice.
You don't need one, but you might want one depending on what you're building. And this is really the point that I'm trying to stress is you might want to build a robot with 10 horsepower motors. And if you get an appropriate motor driver that supports PWM or ESC style of motion control, you could do it with the Linorobot 2 stack. So my point is really that it's a software stack comprising two parts: a set of ROS nodes that talk to the microcontroller on the robot and interface between it and the nav2 stack, and then the firmware that runs on the robot that I'm about to go into how you configure it and show how the degree of flexibility that you have to configure it. And again, just to reiterate the hardware architecture, you've got the robot computer that running the ROS nodes, and you've got a microcontroller controlling the motor drivers and encoders. And the software architecture, you've got the ROS nodes up on a ROS computer, and then you got the micro ROS on the microcontroller doing the low-level hardware interfacing. So more on the why, the easy config file. So you don't even have to actually do any C++ or Python to get navigation plus ODOA, obstacle detection, obstacle avoidance. So it makes it accessible to non-programmers, but with the caveat, obviously, is for any of you who know ROS, you don't want to step into ROS without knowing what ROS is, without understanding the concept.
Hang on a second, Paul. You've jumped into something here. What is this? A separate package or a programming language? Is this the AIDER?
So what I'm showing here is the config on the right hand folder, or the right hand image is a part of the config file for Linorobot 2.
Oh, okay.
So this is the easy config file part of the value prop. So rather than writing your own PID loops and figuring out how to interface to motor controllers, if you define here.
Is this part of the Linorobot documentation?
Absolutely.
Okay,
Yes.
Go ahead. Sorry.
You define your counts per rev for your encoders. So mine has 1,800 counts out of the quadrature encoders per wheel revolution. The wheel diameter is 80 millimeters. Left to right wheel distance is 160 millimeters. How many PWM bits there are, and then you've got flexibility in terms of inverting the encoder signals. So like if your encoder is mounted such that it counts up when the thing goes backwards, you would set a true on this motor 1 encoder INV variable, and then the encoders will go in the right direction corresponding to the wheels. And similarly, you've got controls for if the motor directions like NA and NB are inverted, you can set that to true or false as appropriate. And then you can set the encoder pins. And it sounds like you're rather kind of interested in this file camp. So let me just open the file and show it more fully. If I go into documents, platform IO, projects, Linorobot 2 hardware is the repo that has all of the micro ROS stuff. Firmware is the micro ROS code. Then you got some utilities programs to test sensors and motors and accelerometers. Then you got the config file, and Minibot Wi-Fi config is what's running on that little Minibot robot. And so here's what I was just showing. As well as that, you've got, I'm going to go rather fast in the interest of time here, but you do have control over the PID constants, the covariance matrices for pose and gyro. Here's a section I was just describing, and the pins, which pins on the microcontroller the encoders come in at. So this enables you to like configure it for a tiny or a Pico or an ESP32. Then you get down into the network list section where you can list your Wi-Fi access port, and it's a nice thing. It will write logs to the syslog server, so you can have a syslog server on your laptop and get logs. And then you've got a board and net section where you can like do your own custom thing. So anyway, that's a little deeper dive than I planned on for that config file, but just to express that it's pretty flexible. Okay, so how do you make a Linorobot 2? So I've got a link here to Thomas Chu's Linorobot 2 _hardware wiki. If you go to this wiki, you'll find it's a long page, but I've summarized it into these 11 steps. But it goes through like in great detail if you've got Wi-Fi or serial comms, and if you've got a Pico or an ESP32 and so forth. You install ROS Jazzy, you install and I'm recommending, at this point, I'm recommending Thomas Chu's Linorobot 2 and Linorobot 2 hardware repos. I'll talk more about the upstream repos here in a minute, and the relationship that they have to these. But this is what I've proven to work on a real hardware robot. Then you test the micro-ROS agent connection, like you can just do this with a board, just starting up the micro-ROS like I showed before, and checking that you can actually connect to the microcontroller after you've programmed the microcontroller with platform IO. Because if you can't talk to the microcontroller over your desired comms channel, be it network or serial, then there's no point in building hardware. Then you can connect the IMU to your microcontroller and run one of those utility tests. Then connect again and check that you're getting IMU data out on the IMU data topic. Then it's worth designing and building your robot and customizing your configuration file, testing the motors and encoders, test the LiDAR, launch the robot bring up. Then you should be able to use a keyboard to move the robot, keyboard or joystick to move the robot. And finally, you launch SLAM, save the map, then you launch nav with the map. And then the last step is a small matter of programming. You write some application software to navigate as needed. And so that's in 11 steps, how you make a Linorobot 2 robot run nav2 without any programming except for step 11. When you come to writing application software, obviously you're into programming. So nav2 wouldn't be much use if it required RViz to move the robot, but nav2 has an API for user apps, and a little programming is all that's needed. This code here on the left side instantiates a basic navigator. It defines a goal pose, and then it calls the navigator go to pose method, passing in the pose stamped object. And then you loop waiting for completion while not navigator.isTask complete, get the feedback, and the feedback is how many seconds there are until it's done. And there you have it. You've got your API. From there, you can really go to town. And what I think is what I didn't fully understand before I got this thing all built and put together, and started to experiment with nav2, because I'd not worked with nav2 previously. What I didn't understand is that your user app you can mix and match inputs to the robot. So nav2 will drive velocity commands out on the command val topic when it's asked to drive the robot, but then it drives it somewhere and it stops, or maybe you cancel its motion for some reason. Then your user app can take over and drive command val apps, for example, to approach directly to a cone, because nav2 won't come up and touch an object because obstacle avoidance will prevent it from doing so. So that's a case where you want your user app to say, yeah, I know I'm going to try and touch this cone or grab this can. So don't get in my way, nav2. I'm going to give some motion commands until I sense that I'm actually where I want to be, or whatever your user app needs are. Since you've got micro-ROS running on the microcontroller, you can add your own topics and services down there on the microcontroller. And for that 6CAN application that I showed competing in the 6CAN contest, I found that there's a servo output on the WaveShare general robot driver. So I did a little bit of code that created a subscriber to a /gripper topic or /servo topic, and took whatever was published on that and applied it as a pulse train to a servo, and that operated the gripper. So back at the very beginning of this presentation, where I showed that little robot going and grabbing a can, under the hood, what was happening was this user app had told nav2 to navigate to the approximate region of cans. It had then taken over control and pointed the robot at the can, driven it right up to the can, and then sent down a message on a custom topic to a custom subscriber on the microcontroller that then operated the servo that closed the grippers. So is that magic or what? I think it's, to me, this is pièce de résistance.
I'm a big fan.
Yeah, it's so let me then in the interest of a balanced presentation, talk about the good, the bad, and the ugly of Linorobot 2. So the good is map-based navigation plus ODOA, a variety of supported motor drivers and sensors, etc. Things I've been talking about. There's a Google group for the Linorobot, the URL here, and Thomas Chu, who owns that repo that I gave the URL to before, is very responsive to questions. He's got a discussion tab on his Linorobot 2 hardware repo, and he really tries to help people who have questions. Moving to the bad and the ugly, there isn't a branch labeled Jazzy. That's bad. Even though Jazzy works, there should be a branch labeled Jazzy. The email list is almost comatose, very little traffic. Hard to know if anyone's using this thing. ROS 2 and MicroROS currently based on DDS, and like I said before, doesn't work with my home routers, may not work with yours. That's ugly. DDS, oh my goodness. And then Thomas Chu's forks of the upstream repos have diverged from upstream. So I've made changes to Chu's repos for real robots, while Juan Miguel Gemino, who owns the Linorobot 2 domain name and GitHub repos, has made changes to the upstream repo to support Gazebo on Jazzy. They need to reconverge. So this is ugly. So I had a good discussion with Juan yesterday morning, and I believe he'll accept PRs from me to fix these issues. So, what's happened is there are two repos, and as you guys know, something a sophisticated repo like Turtlebot supports both hardware and simulation of the same robot. So you can run it in sim, run the hardware, and do your debugging wherever you want. So there are two repos that contain the Linorobot software and firmware. There's the Linorobot 2, which contains the ROS nodes, and then Linorobot 2_hardware, which contains the microcontroller firmware. And the upstream repos, Gemino's repos, run Gazebo on Jazzy. I don't know if they run hardware on Jazzy. I haven't tried them. I suspect they don't, because he doesn't have a hardware robot to test them on. The downstream repos, Chu's repos, run hardware on Jazzy. I've made commits to them, pull requests that ensure that. They do not run Gazebo on Jazzy. So here we've got the disconnect between, and they've diverged. So my goal is to merge both of these into a Jazzy release in the upstream repo. The challenges in doing that are there are different branch names in the different the upstream and downstream repos. It's unclear where the common origin is, or if there is one. It's hard to tell what's being pushed upstream. You can get an idea of hopefully this picture on the right summarizes the situation. So
Paul?
it won't be too painful,
Paul?
but yeah.
We need to wrap it up.
Yep. So anyway, that really is the end. That's the end of my presentation on Linorobot, and I'll send the slides to Camp, but just to know that I have a couple of slides here on how to use Aider for creating ROS nodes. This is a quick how-to, a quick start here. What to load, what environment variables to load, how to launch it, and then how to make a ROS node. And I've had great success making ROS nodes. I even had one create something that analyzed the LiDAR scan and identified cans in it by looking for discontinuities. And the overall approach was borrowed from IndieDev Dan, which is to create a markdown file that has a high-level goal description, implementation notes, and then you give it to Aider. And since it's markdown, you can render the markdown as a web page, and you can give it context, you can give it low-level tasks, and this is what I've been feeding it to tell it what I want, and then I tell Aider to go and do it, and it spits me out a well-documented node that I've been very pleased with so far. So that's what I had. I'll wind it up and take questions or comments.
Is that building as a Python? It's writing you a Python script?
I've used it for both Python and C++. Most of my nodes have been Python so far, ROS nodes in Python, but the one that took the LiDAR scan data and found cans was a C++ node.
Oh.
And what I really impressed me about it was the it does some stuff that I don't know how to do. For example, in the Python can find a node, it used a collections.deq, double-ended Q. In the can finder, it used it used one of the RTL libraries to it made a sorted list with a custom comparison algorithm, and that's stuff that many of us who don't do that daily would have to go deep into the web to find examples of how to do it, and it just spat it out and all nicely commented and everything. So been very impressed with that.
Now, with the Aider, how does it compare with the GitHub Copilot or just GPT-4o? Is it
great question?
Better or something?
So they all use an LLM in the back end, and you can choose your LLM, whether it's ChatGPT or I'm using Gemini, but you can just as easy, you can use Open Router, and that lets you choose your LLM of choice. Really, the difference between Aider and Cursor and Chat and Copilot is the front end. So Cursor copies the VS Code model. It seems to me that Microsoft is overtaking Cursor now with Copilot with their agentic mode, because you can now ask the agent to code up stuff. The front end of Aider is a textual interface that wants to run in a Git repo, and so it makes its changes and then it checks them in to Git, and and let's see. So if I go over here. Okay, let's see if we can pull up something sensible. So here's what it checked in. I ran out of time to do a demo here, but so I did where it puts feet : or it'll do like bug fix : or things like that. That's Ada's code, and it so it checks in whatever it changes, and then it has a command line interface that you can say undo if you want to back out the changes that it made. Did that answer your question?
Right, yeah. I mean, it sounds like it's a bit more integrated with actual code development and check and repo management as well.
Yes, and you can ask it to. So one of the instructions that I typically give in my instructions is to update the build files, update the ROS2 control file. So it'll ask, like I say, /add. You use a slash for commands. These files. Then it'll say, it'll interactively come back and say, would you like to add this file to the chat? And you say yes. And
all right, got to wrap it up.
This is great stuff.
Any more quick questions for Paul before we wrap it up here? Paul, thank you very much.
Well, thank you, Camp, and thank you all for your attention and questions. If you don't mind,
share the screen so we can see your face.
Yeah, sure. And if you don't mind, I think I'm going to here we go. Head on off to it's kind of late here in Central Time, so I'll probably drop off the call here pretty soon. But
all right,
thank you.
well, I make a motion this meeting be adjourned. Do I have a second?
Second.
Sure.
All in favor, say aye.
Aye.
Those opposed, say nay. Ayes have it. Meeting adjourned. Thank you. Thank you very much.
Good night, everyone.
Good night, everyone.
Awesome, Paul. That was awesome, man. You rock.
Show us just Ada sometime.
Thank you, Camp. I appreciate it, and thanks.
Yeah,
for
you just drop in and do it for show and tell. In fact, we do our challenge meeting next month, so you could show it off as a challenge. Limited to 5 minutes, though.
We're adopting the HBRC tabletop challenge in DPRG as a kind of like a beginner robot challenge for the exact reasons and scenarios that you all use it.
So no kidding, you're 7:30 Tuesday. I'm doing the 7 p.m. Pacific time ROS discussion group. Might just start off early with your group and then move over to the ROS discussion group. I don't know. I could maybe start something on the East Coast here and have it be like an all-day rolling meeting. No kidding, though. This has been fun.
Yeah, and I'm excited about Linorobot. I really am. Now that I've talked to Juan Miguel Gemino, and he's given me a green light to do pull requests to try and merge these two sets of forked repos back together again.
That would be a great service.
Robots bringing you tokens.
They're going to use either.